In today's lecture, I'd like to talk about a peculiar situation that can arise when dealing with internal rate of return, where you can actually get two or more internal rates of return. I'll illustrate this through an example. Here we have a project with a cash flow structure where it pays $1,000 today, costs $5,000 a year from now, and pays $6,000 in 2 years. So this might be, for example, doing a consulting contract where you're getting an advance on the contract, you're paying some money to do it a year from now, and when the project's finished 2 years from now, you're invoicing and receiving the full cost for it. And we want to know what its internal rate of return is. Well, we've got $1,000 today. We've got that's a payment. We've got a cost of $5,000 a year from now, which I can bring to present worth at some unknown interest rate, which will be the internal rate of return over 1 year. And we also have $6,000 positive, which is a payment, 2 years from now, which will bring to present worth at an interest rate over the 2 years. And if I set that equal to 0 and solve for the unknown I, that'll give me the internal rate of return. That's the standard formula. Now, I can do this through trial and error, which I would normally do for a more complicated formula. But because we're looking at a 1 year and 2 year period here, we can do this through basic principles. I'm just going to divide by 1,000 and substitute in the formulas for these present worth calculations. And it'll give me 1 minus 5 divided by 1 plus I plus 6 divided by 1 plus I squared equals 0. If I multiply through both sides of this by 1 plus I squared, 1 plus I squared on the right-hand side, of course, remains 0. I get 1 plus I squared minus 5 times 1 plus I plus 6 equals 0. If I multiply out this I plus 1 plus I squared and simplify, I will get the following. I squared minus 3I plus 2 equals 0. Factoring this left-hand side gives me I minus 1 times I minus 2 equals 0. And of course, that gives you two solutions of I equals 1 or 2. In terms of the internal rate of return, that gives an internal rate of return that implies a internal rate of return of 100% or 200%. Now, that math is straightforward. Arithmetic is straightforward. And you can verify that that's perfectly correct. But it's very peculiar. Because the internal rate of return, we have this intuition now about it, that it's the interest rate an investment earns. And we have a project here with cash flows, which, as an investment, seems to earn two different interest rates. And that doesn't make sense. You can't earn two different interest rates at the same time. So let's break this down and do it step by step and see exactly what's happening here. Let's work on this problem 1 year at a time. Year, end of year, at 100%, at 200%. So, at 100% interest, in the first year of our project, we get $1,000 at the beginning, and at the end of the year, at 100%, that $1,000 becomes $2,000 because it's earning 100% interest, so it doubles in value. However, we have to pay $5,000 at the beginning of the second year, leaving us minus $3,000. Right? So we start with $1,000. It earns 100% interest. giving us $2,000. We have to pay $5,000, so we're out $3,000 at the end of the first year. At 200%, it'll be $3,000 because we earn 200% interest on that $1,000. We have to pay the $5,000, and we're left with minus $2,000. At the end of the second year, at 100% interest, that minus $3,000 doubles to be minus $6,000. We get $6,000, and we're left with 0, which is the way it should be. At 200% interest, we have minus $2,000, tripling in value because it's 200% interest, equaling minus $6,000. We get $6,000, and then we're left with 0 again. So even doing this a year-by-year, step-by-step way gives us the right answer. It still says that we're getting both 100% and 200% interest. So, this really is peculiar. Well, let's see what's happening here. We've got a peculiar situation, which I can illustrate graphically. If we have, if we're solving an equation for an unknown interest rate, for example, one like this. Here's the equation, which is a function of I. In these internal rate of return equations, the left-hand side, we can accumulate all of the components. As we did here. On the left-hand side, we have 1,000 minus 5,000 times the present worth factor and plus 6,000 times the present worth factor equals 0. So this is f of I. It's a function of I, which we set equal to 0. And so that function of I, depending on the particular value of I, will have a different value. And what we solve for is where it really crosses that x-axis. That's where the function of I is equal to 0. Now, by and large, for most such functions of I, such equations that we're solving for an unknown interest rate to determine our internal rate of return, they are either monotonically decreasing or monotonically increasing. A shape like this, sort of constantly going down, or a shape like this, constantly going up. So they only cross that axis once. However, it's possible under particular types of cash flow structures for that function of I to cross twice, like that. And that's what's happening here. It's crossing once here at 100%, and it's crossing once here at 200%. Now, these particular functional shapes occur under particular circumstances. They occur where the accumulated cash flow in a project changes sign more than once, is a mathematical way to put it. There's also an intuitive interpretation. Let's have a look at our cash flow diagram for this problem. What we have is a situation where we're getting money, we're having money coming into the project before we pay money out to the project. That money that comes in is cash, if you like, that we have that is not bound up in the project. If we, for example, invest in a project first and they get savings later, the money we invest is in the project and stays in the project and generates earnings for us. Here we have money that comes to us first without us having any money in the project. And when we calculate internal rate of return for this $1,000 for the first year, if we think of it as being part of the overall project, we're saying we can earn 100% interest off it, at least 100 to 200% interest. But think about that physically. If you get your advance for your consulting contract, what are you going to do with that money? Are you going to earn 100% interest on it? Probably not. You're probably going to put it in the bank and earn 4%, because it's not, that money itself is not earning money yet. It's only once that money is bound up in the project, once you make this investment of $5,000 a year later, that that this money actually starts earning the 100% interest or whatever the internal rate of return is. So in general, these situations occur where you have, if you like, cash in your hand. You can physically imagine having that cash that's not being used. It's not earning money as part of this project. It has to be invested elsewhere. Typically that occurs in this kind of situation where there's an advance. There's money that occurs before an expense is made. But in fact, it can occur anywhere in the cash flow cycle. That's why I say it's whenever the cumulative cash flow changes sign more than once. So that you accumulate this cash, and it's negative for a while, then changes positive, and then changes negative again. That's a double change in sign, or vice versa. Then, at some point in time, you have this cash in hand. So, in a subsequent lecture, I'll talk about how to deal with that problem, what to do to correct this multiple 2 or more internal rate of return problem. But what I want to do in this lecture is to help you recognize when that will occur. It's when you've got a payment received for a project before a payment's paid for a project, so a receipt before a disbursement. Or in general, though you won't see too many cases like that in this course, it can also occur that somewhere in the project itself, there will be cash that has to be invested somewhere other than in the project. Thank you.